Good morning, Algebra 2 students, and happy Friday. Today we're going to be looking at lesson 65 together. The title is Advanced Substitution. It's not going to be something you're not familiar with because you all know how to do substitution. What's going to make it a little bit more complex is that we're going to be working with 4 different equations with 4 different variables. And we're going to learn to take one of those equations, substitute it in for another, using yet another one to substitute into maybe the same one or another one to solve for all 4 of these variables. Okay, so I'm going to bump down here. We're going to come back up and build that one in your notes in just a moment, but we're going to look at this particular one right here. So notice, one of the things that can make this a little bit more advanced or even just complex or confusing, if you will, is the fact that we're not using simple variables like x and y and z. We're using subscripted variables, which can make it a little bit more difficult to keep track of. But don't let that throw you for a loop. At least understand that each one of these counts as one variable. So we have r with a little subscript of w, t with a subscript of w, r with a subscript of b, and t with a subscript of b. And remember, sub just means underneath. So those little variables that are underneath the larger variable is a subscripted variable. And so that's what they call these. These are 4 different subscripted variables. And you'll notice up top here, we have to solve for each one of these, rw, tw, rb, and tb. So in the end, we want to try to figure out each one of those subscripted variables values. So let's look at, I'm going to move those up here just to get them out of the way because I won't need them until I solve, and then I'll go back up and fill them in one at a time as we solve. So let's look at all 4 of our equations here. I have rw times tw equals 6. I have rb times tb equals 6. I have rb equals 3 times rw. And finally, d says I have tb equals 2 minus tw. So you can notice here, if you will, that many of these are shared. You see them more than once within different equations, and that's okay. We're going to try to figure out, first of all, what we can use as what's called a base equation. We want to know what the base equation is because that's our starting point. And once we identify the base equation, we can start our process of solving and going towards isolating variables so we can figure out the values of each one of these. So let's think about what our base equation needs to be. Well, I'm going to start at A and I'm going to look and I think, well, this could be a potentially good base equation. So could this one, right? They almost look the same. They're just different variables. Look at C with me. C gives me the value of a variable. So C is going to help me determine which one of those A or B equations might be a good one to start with. Well, since I know that RB is equal to 3 times RW, I'm going to choose B as my base equation. Okay, and I'm going to write that down here. RB times TB equals 6. Okay, that's my base equation. Now I'm going to take that C up here and I'm going to substitute in for this first RB as 3RW. Now if I was in front of you at the whiteboard, I'd be pointing, so you kind of lose that when we work together on a video recording. But notice what I did. All I did is I took for RB, I substituted in 3W, and where did I get that? Right up here up top with equation C. Okay, so that's all I did. I substituted in, instead of writing RB again down here, I wrote 3RW in place of RB. Okay, now let me remove some of this because I don't want to get this too busy for us. Whoops. All right, so let's solve this part. What do we get here? So let's make sure I have everything written in here correctly. Okay, and actually, in this same step, I notice on my notes here, I have it written in 2 steps. So we're going to combine this into one step because if you will notice with me, I'm going to erase this right here. If you'll notice with me, I actually have a value for TB, don't I? So instead of writing TB again down here in our base equation, I'm going to fill in the value of TB. TB's value is 2 minus TW. There we go. So that was very helpful to have equations C and D that we could use right up front in our base equation. Okay, now we can do our multiplication. So I have 6RW minus 3RW TW equals 6. Okay, now Notice with me, second step here. Here's the equation I'm left with. 6RW minus 3RWTW equals 6. I'm going to rewrite that right here just to kind of keep myself organized. And I want you to notice what A says up here. Look at equation A. We have a value for RW times TW. It's 6. So I'm going to come back down to where I'm working in my workspace, and in RWTW, I'm going to insert 6 right there. And let's just keep the rest of it the way it is. But notice what has happened. In doing all of this, I've been successful, excuse me, in narrowing it down and isolating myself to one variable. So now I'm going to be able to figure out what the value of RW is. So let's work this through. I'm going to have 6RW minus 18 equals 6. We'll add 18 to both sides. We have 6RW equals 24. We divide by 6, and we end up with a value of 4 for RW. So I'm going to go up here, and I'm going to write that in. So we have found the first variable is RW. Now let's look at the next thing we're going to do. I'm going to put a line here, and I'm going to come up here and put number 3. So for number 3, I'm going to go back, and I'm going to grab another one of my... So far, we've actually used all 4 of those, haven't we? But really, what have we really used? We used our base equations. I'm going to put a big check mark right through that. We did use RB. We did use this one. So we've used B, C, and D. We used A as a substitute, but we've not actually completely used it, and we may end up using that again as, when I say base equation, this was our base equation up here, number 1, okay? But we might use letter A up here again as our original equation. We might do that with several of these. So let's move through this. So, okay, let's look at the next thing. So if I have RW, I'm going to look back up here in A, B, C, and D and see where can I use RW to solve for another variable. Well, I'm going to look here at C. Look at C. RB equals 3 times RW. I'm going to write that down here, because if I can fill in RW, it would be 4, right? And look at, now I'm going to have one variable to solve for. We can figure out RB is equal to 12. So we were successful in figuring that out. RB is 12. We'll write that in right up here. Now let's keep moving. I'm going to put another line here. What's the fourth thing we need to do here? Well, we have RW and we have RB. Now we need TW and TB. So let's look and see, can we get TW? TW, we could probably go over here and use A, couldn't we? We could take RW times TW equals 6. And since I know RW is 4, I could solve for TW. Whoops. Divide here. TW equals 3/2. Okay, so there is the value for TW, is 3/2. And then lastly, we have one more variable to solve for. So I'm going to write one more little column over here for number 5. Number 5, we're going to try to solve for the last one, which is TB. And so you ask yourself, well, where do I see TB? I have it in a couple of places up here, don't I? I have it in B and I have it in D. So I suppose it doesn't really matter which one we choose, but I'm going to go ahead and choose letter B. I'm going to fill in what I know. RB is 12. So I have 12, TB equals 6. I'll divide by 12 on both sides. And TB is equal to 1/2. So all 4 variables were solved for correctly. I've been able to do that by using all 4 equations kind of like interchangeably, right? So one substitutes for another, another substitutes for another, and the process goes on, and we're able to in the end, find solutions for each one of those variables. So let's go back up top here. We're going to do this one together now. We have 4 equations. RP times TP is 693, and all the way across, you might want to take a moment to look at all of those. And then off to the side over here, let me find my packet. Off to the side, I'm going to make a little bubble over here where we're going to write down all the variables that we're solving for. So RP, we're going to solve for TP, we're going to solve for RC, and we're going to solve for TC. Okay, so there's our 4 variables we're trying to solve for. Remember, step 1, what's your base equation? Identify that base equation based on the best method of substitution, okay? And actually, as I'm looking here, we do need to make a rearrange up here. So before we find that base equation, let's rearrange letter D so that we can have this set equal to a variable. So let's have this set equal to TP. That would change this to 12 minus TC, right? If I move TC to the other side, I end up with TP equals 12 minus TC. So therefore, not only do I have a variable here, RP is equal to something, but here TP is equal to something. And that's going to serve us well when we're identifying our base equation. So we could choose, by looking at it, we could probably start right off with A as our base equation. RP times TP equals 693. Because as I went across here and I looked at all 4 of these really, I could stop right here and notice, okay, right here, RP is equal to something. So I'm going to go back and grab the first equation as my base equation. Okay, now I'm going to move on through this. And I'm going to say right here is where we're going to start solving. So there's my Roman numeral number 1. And this was equation A. Let's fill in what we have. So RP, according to C, is equal to 3RC. So we're going to fill that in here. We're going to put 3RC in for RP. And if you look at D, we know that TP has a value. So we're going to put something in for TP. 12 minus TC equals 693. Now let's make a multiplication here. Distribute this. You're going to have 36RC minus 3RC TC. This is looking pretty good because look here, RC TC right up here is 165. So let's plug in 165. And the beautiful thing about this now is that I've narrowed it down to 1 variable. So now I know I can solve for RC. So let's just keep this thing going. I'm going to add 165. Oops. I forgot to write in my 3. Put your 3 right here. Make sure you didn't forget that. Hopefully you've been yelling at me, Mrs. Quigley, you missed it. Okay, here we go. So 36 RC minus 495 equals 693. So go ahead and solve through. Let's see what you get. And you should get RC is equal to 33. So we're going to go up here and we're going to fill that in to RC. Third one down here, 33, off to the far right. Let's bubble that in so you see where I'm writing. Okay, that is these are what we're solving for right over here. Okay, over there in yellow. All right, Roman numeral number 2. We still need 3 more variables. So I'm going to go ahead and look at what I've solved for is RC. So I'm going to go back up into A, B, C, and D and see where would be the easiest place to plug in my value for RC. Well, by the looks of it, I think it's right here. This equation that I highlighted in yellow up top there, equation C. So let's write that down. So you're going to have RP equals 3RC. And we're going to substitute in. Now we're going to solve for RP by multiplying 33 by 3. And RP is equal to 99. So RP is 99. Let's go fill that in up to the right. Third one, Roman numeral number 3 right here. Roman numeral number 3. Now I have RC and I have RP. So I look back up top here and I think, where can I actually, what would be the best place for me to go now? So far, what have I used? I've used RP, TP was my base equation. Might use that again. I've used RP, I've used this one to solve for RC, so I'm not going to use that one again. Let's use RP, TP is equal to 693 because I know what the value of RP is. It's 99. And that will allow me to solve for TP. And pretty quickly, actually. TP is now equal to 7. So I've gotten 3 out of my 4 variables, which is great. And we'll need one more calculation to figure out TC. So I have RP, TP, RC. So look back up at your 4, see where that would be a best fit. I'm going to choose to use the RC-TC equals 165. Because why? Because I have RC and I need TC. Now, could I have used a different equation? Yes, I could have. I could have chosen to use anywhere else that you're going to see TC. So look in, let's see, I used B, but I could use D also, couldn't I? Because I know that TP is 7, so I could put 7 plus TC equals 12, and I'm still going to get the same exact answer that way as I did this way. So are you stuck with one specific way? And if you don't know that one specific way, you're not in a good shape? No. There might be a couple different ways that you can work through this to solve it. But you do have to identify your base equation based on usually C and D. Now, they may have them mixed up, so you need to watch for that. But you're always trying to find the base equation based on what do I know that I can use to substitute in right away. Okay, so in this case, we used C to help us with that, and actually even D. We used both of those to get us started. All right, so let's do the practice one together. And in your book, you'll find that on page 277. Page 277, there's only one, I suppose, because it's kind of long. So I'm going to go ahead and write across, I'm going to use blue this time, and I'm going to write across the 4 equations that they give to us. Letter A is RP, TP, and if you would like to right now, you could pause the video and you could try to solve this on your own and then come back, and you can even scroll forward and see if you got the right answers. And if you didn't, then you can scroll back and you can watch me work through it. If you get them right, you won't have to watch me do it. You can just check your answers. If you get it wrong, then you'll stay with me a little bit longer and make sure you can find your mistake based on how I explain it. And then you are free to go start your lesson. And letter D is TP plus TC equals 12. Okay. So the first thing I notice is in A and B, either one of those might turn out to be my base equation. I'm not sure which one I want to use yet, but I'm going to choose it based on C because that first one over there gives me a value of RP being equal to something. So I know that if I choose A as my base equation, I can start off by plugging in the value for RP. Now I'm going to need, hang on a second here. Okay, sorry, I had to reach for something. I can also take that base equation and I can put TP in there also and get yet another variable in there. So let me see, do I have a value for TP? I don't, do I? But if I look at D and I get creative, I can rearrange it and make it equal to TP. And if I do that, I move TC to the other side and I have 12 minus TC. Right? That's much like what we did up here, actually. In fact, it's exactly, isn't it? Hope I didn't do, is that what I just did with you? Oh, no, slightly different. Okay, good. Whew. All right. Okay, so now I have a value for RP and for TP. So let's use our base equation. And let's substitute in what we have. So RP is 3RC. TP is 12 minus TC, and that's equal to 288. Distribute that, 36 RC minus 3 RC TC equals 288. Now, do I have a value for RC TC? I sure do. It's 108, isn't it? So let's plug that in right here. I'm quiet because I'm just working through this. This is just basic algebra that I'm doing right here. And you shouldn't really need to hear me talk through that. So I'm going to let you work on that on your own as I'm solving to the end of this for the variable RC. Use your calculators. Don't count on your head, and don't waste time by going off to the side. Grab a calculator and figure that out. Okay, so I figured out that RC is equal to 17. Okay, so now that's the first one. I didn't leave myself much room up here to write what each variable is. So I'll just color mine in here in yellow. I'll highlight them as I get them. Okay, so there's RC. Now let's do the second thing I want to do. I want to use RC now to be plugged in somewhere simple. So as I look across, I'm going to go up here and grab letter C, because I see that if I do one quick simple calculation, I can figure out RP by plugging in RC's value. And 3 times 17 is 51. So there's the second variable taken care of. Okay, we have 2 more to go. Number 3. Okay, now I have a value for RC and for RP. So let's get creative here, and I am going to choose RC to put into equation B. And while I have that answer, I'm going to just pull out the answer key to confirm that we get a something that looks like that. Yep, we sure do. So there is the value of TC. So don't be scared if you get some weird looking answer like that. That could very well be it. If you've done everything mathematically correct, you'll come out with that too. And finally, let's go over here. I'll make another column for the fourth thing that we're going to do. And the fourth thing that we're going to do here is take our values that we have and use those to satisfy the last variable we have. Let's see, we have RC, RP, TC. We need TP. So let's go find something where there's a TP. There are 2 of those, but I'm going to choose letter A. I'm going to choose RP, TP equals 288 and plug in RP is 51 equals 288. And that will actually, believe it or not, reduce. You can divide by 3 here and get 96 over 17. And remember, when you're trying to reduce, it's always easy if they're even. You always know, well, at least I can divide by 2, right? A good way to know if you can divide by 3, do you remember this little rule? If you take a number, let's take 288 and let's take 51. How did I know those were divisible by 3? Well, I'm testing in my head, first of all. I already know just from working with the number 51 so often that that's divisible by 3. But the rule for that, to be able to know, is if I add those 2 together and they add to a number that's divisible by 3, then I know the whole number is divisible by 3. So let's test 288. If I add all 3 of these together, 2 plus 8, I'm going to get 18. And 18 is divisible by 3, so the whole number 288 is as well. Okay, guys, so that is all that you need to get started on your lesson for today. We did 3 examples. 2 of those you have in your notes, so you should be good to go. Have a good weekend, and remember to watch for a lesson on Monday. Alrighty, we'll talk soon.